Hey, today we have the Legend of JEE Mains. We have this integral from negative pi by 4 to pi by 4, 1 over 1 plus e to the power x cos x times sin to the power 4x plus cos to the power 4x dx. This integral is especially tricky because we have to use the King's rule over here at first, and then we will use some beta gamma functions or use substitution. Uh, Firstly, if you don't know what King's rule is, let me show you over here. So if we have this integral from a to b of f of x dx, this integral is equals to integral from a to b f of a plus b minus x dx. This is King's rule, and for our case we have b as just negative a. So when b is just negative a, so this will be f of x dx should be equals to integral from a to negative a. We will have f of negative a plus a, so that's eventually 0, and negative x dx. So this is the special case of King's rule that we will use in this problem. F of x dx integral from a to minus a is equals to f of minus x dx from a to minus a. So if this be f of minus x will be I will do it over here. So our I is integral from minus pi by 4 to pi by 4, 1 by 1 plus e to the power x cos x sine to the power 4x plus cos to the power 4x dx. This integral will be equals to this should be equals to I equals to integral from minus pi by 4 to pi by 4, 1 by 1 plus e to the power minus x, and then cos of minus x, that's cos x, and then sine of minus x to the power 4, that's just sine of 4 to the power x, and cos of minus x to the power 4, that's just cos to the power 4x. Since the power is even over here, it doesn't matter, and dx. Now after this we can just take the negative exponent in terms in the denominator and then take LCM. Integral from minus pi by 4 to pi by 4 e to the power x cos x, and then e to the power x cos x plus 1, and sine to the power 4 cos x plus cos to the power 4 x dx. So this is our I. Now if we add these two integrals, we will get a nice simplification. That is, our 2I is equals to integral from minus pi by 4 to pi by 4, 1 plus e to the power x cos x by 1 plus e to the power x cos x by sine to the power 4x plus cos to the power 4x, and then dx. And these cancel out, and you see we have got a really simpler form. So we have 2I is equals to integral from negative pi by 4 to pi by 4, 1 over sine to the power 4x plus cos to the power 4x dx. Now since this is an even function, we can just change these limits of integration into 2 times integral from 0 to pi by 4. So that will help us cancel the 2 over here, and we get I equals to integral from 0 to pi by 4, 1 plus sine to the power 4x plus cos to the power 4x dx. Now we can use a standard technique of dividing numerator denominator by sec. So we will divide by sec. We will multiply by sec to the power 4x over here, and we get integral from 0 to pi by 4. Sec to the power 4x by tan to the power 4x plus 1 dx. Now if we let tan x as y, now if we let y equals to tan x, our sec square x dx will be dy, and the remaining sec square x can be changed into 1 plus tan square x. So that's 1 plus y square. We have I equals to integral from 0 to pi by 4, 1 plus y square, and then dy by 1 plus y to the power 4. Now it's a nice place to use beta gamma function. We can just let z as y to the power 4, then we get dz as, but before that we get z to the power 1 by 4 as y, and then 1 by 4 z to the power minus 3 by 4 dz as dy. So we have I equals to, but before that, since we have let y equals to tan x, we have to change the limits of integration as well, which I haven't. And at x equals to 0, y equals to tan x will be 0, and x equals to pi by 4, it's 1. So yeah. Now the integral is from 0 to 1. Y square is just 1 plus z to the power 1 by 2, and then we have 1 plus y to the power 4. So 1 plus y to the power 4 will be 1 plus z, 1 plus g, and dy will be 1 by 4 z to the power minus 3 by 4 dg. Now we can take the constant out. 1 by 4 integral from 0 to 1, and z to the power minus 3 by 4 plus z to the power minus 1. Oh, I don't know why this happened. This should not have. Okay. But this is z to the power minus 3 by 4, yeah. In the integral from 0 to 1, z 1 by 4 in the out as constant, and z to the power minus 3 by 4 plus z. I guess I need to delete some of the text. Yeah, we will now continue with this thing over here, but before that I guess I need to delete some of this text over here, because it's been a lot of text to it's getting high. Delete. Okay, so now I guess it will be fine. So we had I cos integral from 0 to 1, and we had 1 plus z to the power 1 by 2, 1 by 4 z to the power minus 3 by 4 by 1 plus c dg. Now we can bring it a bit down. we can have constant in the out. Yeah, and then integral from 0 to 1. This will be g to the power minus 3 by 4 plus g to the power minus 1 by 4 by 1 plus g dg. Now we know that uh, our integral, now we know that mm, integral from 0 to 1 x to the power m minus 1 plus x to the power n minus 1 by 1 plus x to the power m plus n. This is actually beta function, beta of m and n. And we see that we can take our integral also in the required form, and that's pretty lucky thing for us. We have integral from 0 to 1 x to the power 1 by 4 minus 1 plus x to the power 3 by 4 minus 1, and again 1 by 4 and 3 by 4 sum up to 1. So 1 plus z to the power 1 by 4 plus 3 by 4. So now we can use this and we get 1 by 4 and beta of 1 by 4 comma 3 by 4. This is being too much. This is being too much here. So it's actually 1 by 4 and then beta of 1 by 4 comma 3 by 4. Yeah. Now we can use a gamma function. That's gamma 1 by 4 and then gamma 1 minus 1 by 4 by gamma 1. Gamma 1 is just 0 factorial, that's 1. And gamma of n, gamma of 1 minus n, this product is equals to n by, sorry, pi by sine n pi. No, gamma of n, gamma of 1 minus n is equals to pi by sine of n pi. So if we use that, this will be pi by sine of pi by 4, and sine of pi by 4 is actually 1 by root 2, and then 4 times 1 by root 2 is 2 root 2. So this is equals to pi by 2. So that's the answer. I hope you got this. And there's also an alternative way where the integral of 1 plus y square by 1 plus y to the power 4, this can be done with some manipulation and use of substitution, and I want you to try how do we do that. I hope you got the solution, how we solve this integral, the Legend of JEE Mains. Thanks for watching. Look forward to seeing you in the next video.